Now that we've defined it, let's go ahead and look at using molarity and applying it in some different instances. So I have a problem. The concentration of sodium chloride, so NaCl, in blood serum is approximately 0.14 molar. What volume of blood serum contains 2.0 grams of NaCl? And we're given the molar mass of NaCl. I think that's going to disappear, but this would be a case. This is kind of an example problem where the purpose of this problem is it's a molarity problem. You're going to need to use the molar mass, so I'm going to go ahead and give it to you. A lot of cases I'm going to give it to you because what I want to focus on is the actual molarity part. I'm not testing whether or not you can compute molar mass in this problem. Do you know how to use it, though, is going to be a more important issue. So if we think about what do we want here, volume of blood serum. So one of the things, blood serum is not a pure substance. So that's going to be a solution here. So we're definitely looking at a solution. So this would be another like volume of solution. What do we have? We've got a couple different pieces of information. First, we can see that it is 2 grams of NaCl. Again, you'll note that word, the contains, that's a sign that that's solute. So we have mass of solute that's given to us. We are also given that it's 0.14 molar concentration. One of the things we want to be mindful of is that molarity, even though it looks like a single unit, is just a capital M, it still is, one, it has an equation associated with it, and it is a compound unit. It is moles per liter. Okay, even though we write it out as capital M, it is moles per liter. So that is a sign, you have an equation, that's something you can work through, and moles per liter could be used as a conversion factor. So molarity is our kind of setup, moles of solute, volume of solution. So whenever we see an M, we can always use the equation associated with it. We can also see explicitly that that value has an inherent compound unit in it, moles per liter, that can be used as a conversion factor. All right, concentration of sodium chloride in blood serum is approximately 0.14 molar. What volume of blood serum contains 2.0 grams NaCl? All right, so we know what we want is what volume of blood. And we're given 2 pieces of information. Okay? And so one of the things that we have is 2 grams of NaCl and 0.14 molar. We want to think about which one of these can kind of be related, or would we expect to be able to work through to volume. And so one of the things, it looks like normally the things that we look for are kind of the similarities of the units, something like that. So this volume would just be one amount, right? So milliliters or liters, gallons, whatever. And so this 2 grams would also be an amount. And if we think about it, we can look at this word contains. When we see that it contains the sodium chloride, that means that is dissolved in blood serum, which is the solution. Then when we see this 0.14 M, it looks like that's a single unit as well, but molarity is a compound unit. So there's a couple implications of that. First is the fact that there is a equation associated with that molarity. So we would imagine it's going to be 0.14 molar is equal to our moles of NaCl divided by liters of our solution, which in this case is blood serum. Okay. And so what we wanted was a volume. And so that is this. So we want this liters of solution, liters of blood serum. So the question is, do I have a number for moles? And the answer is no, but I have grams of NaCl. So what I can do is I'm going to be able to do a conversion. I have the liters of NaCl, and I know that I have 2.0 grams of NaCl, and I know that for NaCl, it is 58.44 grams per mole, right? That was given to me. as we start to work for these more complicated examples, I'm going to give you molar mass because the purpose of a problem like this is, can you work with molarity? It is not, can you compute the molar mass itself? I'm going to give it to you. I'm not going to tell you how to use it. There's a lot of numbers up here, and only one of them, the 2 grams, actually jives with that molar mass. So let's go ahead and turn our grams into moles. So I have the 2.0 grams of NaCl, and I'm going to multiply that by I have 58.44 grams of NaCl. Again, that grams, the number of the molar mass, stays next to the grams when you're doing a conversion. And on the top is 1 mole of NaCl. That per mole means it is 1 mole. So I do that conversion, 0.034 moles of NaCl. We know for every 58 grams of NaCl is a mole. I only got 2, so not a lot of moles of NaCl. But that is, in fact, the moles that I'm looking at. So I can take that number, these numbers of moles, and plug it back into here. And so what I can do is I can end up with, I have 0.14 molar is equal to 0.034 mole NaCl divided by liters of my blood serum. Okay. So I know that's what I want. So I'm going to rearrange my equation. I'm going to multiply that over to this side. So I have liters of serum, multiply my 0.14 molar is equal to 0.034 moles. This is a common issue. You can't just divide 0.14 by the 0.034 because the liters of serum is in the denominator of a fraction. It needs to get out of that denominator. So this algebra is one of the most common mistakes that I saw, or that you'll see in these sorts of problems. And so you want to be sure that you take care of getting that liters of serum out of the denominator, up and out, and then you want to divide by this. So liters of serum is equal to 0.034 moles NaCl divided by 0.14 molar. Now, when we look here on face, it looks like our units are not going to work out. But when we have molarity, molarity inherently means moles per liter. Whenever we see molarity, that is a moles per liter, and we can use that, rewrite molarity as moles per liter. So I can rewrite this, 0.034 moles NaCl divided by 0.14 moles of NaCl per liter of serum. And you see that those moles are going to cancel out. I have 1 over liters of serum on the bottom of the fraction, but just I invert that. So numerically, I just do the division, 0.04 divided by 1.4, and I get 0.24. And then my units are just going to be liters of serum. So I've gotten 0.24 liters of serum to be my answer. I can take that. 0.24 liters is kind of an awkward number. I could easily convert that 240 milliliters if I so desired. That'd be a bit more common representation of that volume. But all I'd asked for was a volume, and 0.24 liters certainly works. So we know that when our molarity, whenever we see a capital M, we probably want to turn that, know that we have an equation we can work with. Grams always needs to be converted into moles there. And then it just becomes a matter of, once we plug in that moles, rearranging that equation, getting our units all kind of squared away and figured out like that. And so we can use molarity as a way to determine, what's in something. How much is in this amount of solution. We're using really molarity as a way to relate an amount of solute with a volume of solution, right? And this is where we can start to see, it is moles per liter here. That means you can use it as a conversion factor to relate between those two things. And in fact, from here on out, there's actually a slightly different way that we can work through this problem. I want to show using the idea that molarity as a conversion factor. We can avoid doing a little bit of algebra. So we're going to start from this. So we have that moles of NaCl. So what I'm going to do is I started with 0.034 moles of NaCl. And I'm going to use the fact that I have 0.14 molar, which, as we said when we were dealing with the units in the algebra, that's 0.14 moles NaCl per liter of serum. And so what that means is this is moles per liter. So what I can do is I can actually set it up like a unit conversion problem, where I want to go from moles of NaCl to liters of serum, which is my solution here. And I'm going to take these molarity numbers, right? I'm going to take this molarity number that I have up here, and I'm going to use that. The 0.14 moles stays next to the moles, 0.14, and per liter is the same as 1 liter of solution. And so you can see it's 0.034 times 1 divided by 0.14. It's all the same arithmetic that we did on the other side in the algebra, canceling out your moles, and you're left with 0.24 liters of serum. Both of these approaches work just fine. If you're more comfortable with the algebra, using the equation, rearranging it, or if you like the idea of using molarity as a conversion factor. This right here is molarity. So we can use molarity as a conversion factor. You can go from volume to moles. One thing that's important to note, that always has to be liters in there for your volume when you're using this approach. But either way, each method works. You can use your algebra method if that seems, it's usually a bit more kind of tedious, especially if you're working out with the units. This is a little bit cleaner, but sometimes people prefer working with algebra. Whatever it is, whenever we see molarity, we can either recognize that it's either an equation or it's a conversion factor, and we can use it as such.